so next let's explain formation of negative ion. How do we explain anion formation? Why does a fluorine atom tend to become an ion with a negative 1 charge? In fact, fluoride, negatively charged fluorine ions, you only find it in nature with a negative 1 charge. You can't find fluorine with a negative 2. This doesn't exist in nature. You don't find fluorine at a positive 7. Well, if you're going by the tendency to become isoelectronic with a noble gas, okay, fluorine, in order to become isoelectronic with a noble gas, either has to lose 7 electrons, okay, to become isoelectronic with neon. That's going to require too much energy. We've already seen that every time you remove an electron from an atom, it gets harder and harder to take out the next one. But why does it gain electron? In fact, when a fluorine atom gains an electron, it actually releases energy. Okay, so it does gain some stability there. So from 1s2, 2s2, 2p5, okay, your fluorine atom becomes 1s2, 2s2, 2p6. That's your fluoride ion. Okay, that actually releases energy, and the energy release there is called the electron affinity. So we say fluorine has a high electron affinity. Okay, so that is what tends to happen with fluorine when it interacts with other atoms. It has a tendency to acquire an electron instead. F with a negative 2 charge, okay, is never observed in nature, and the reason for that is, look what happens when you have fluoride, we say has a neon-like configuration, right? 1s2, 2s2, 2p6. If you add one more electron after 2p6, what comes next? 3s1, right? So you have 1s, 2s, 3s, 4s. Remember, this is the 2p, this is the p block on the right. 2p, 3p, 4p, and so on. So after 2p6, you get 3s1. Well, think of it this way. So you have your fluorine atom, fluoride ion with 10 electrons, isoelectronic with neon, right? You add one more electron to that to get F with a negative 2 charge. That one extra electron is going to be out here in the third shell, okay? And that electron is not likely to stick around. So F with a negative 2 charge is never found in nature.